So as discussed yesterday, we will first look into TCP IP all layers. Okay, then we will see the animation of how OSI layer works. Okay. So mostly these things I'll try uploading in YouTube. I'm trying to record these things. Later also you will be able to watch this. So where did we stop? Did we stop at network layer yesterday? This is where we stopped, right? We discussed like what are the things which are being done at network layer. Okay. So next is transport layer, as discussed with respect to OSI model. Even in TCP IP also, when I consider this transport layer, it has to provide service from one process to another process. Okay, and it is taking information from application layer and providing segments. Okay, messages will be coming, segments will be going to network layer. At the other side again, it will take services from network layer and provides services to transport layer. Always remember, takes services from below layer, provides services to above layer. Okay, it means like compared to below layer, this is superior. Okay, with respect to functionality, I am not saying with respect to who is greater here, but someone at the bottom, they have to provide services to the top layer. Okay, so like that, this transport layer will be working. So we have several functions over here. The first one is segmentation and reassembly. So can anyone say why we need segmentation and reassembly here? So if I consider a particular packet is there or message is there, this message will not be delivered as it is. Okay, I cannot deliver message as it is because the size may be bigger. Okay, so what we will do, we'll try to have like that some segments we will be doing, and these segments again packet network layer will be taking and making packets. Again they will be made fragments. Okay, and we will be giving some numbering here. Okay, so like that we will give some numbering. We will give some numbering. So these are segment numbers we can see. Okay. So at the other side, yesterday we have seen like network layer is providing connectionless service. That means you are not establishing a connection from source to destination. Okay. In that case, what happens? I won't be receiving segment 1 first always. Okay. There is no condition like segment 1 will be received first. There are chances like first I will get 2, then I will get 3, then I will get 1, then there are chances like 4 will come, then there may be a chance like 7 will come, then 5 may come, then 6 may come. Like that the order may vary. So I cannot give the same message to application layer, right? Okay. So I need to arrange these things. So this segmentation and reassembling. Reassembling I cannot do in whatever the manner I want. Okay, it has to be done in proper manner. Like you need to arrange back in 1, 2, 3, 4, 5, 6, 7, like that. Okay. So split the data from top layers into segments as per the need and reassembling those things. This is the first task which transport layer has to do. Okay. So segmentation, if your network is not capable of handling that big message, you do segmentation. Okay, at the other side you take care of reassembling those things. Then port addressing. Any idea what is port addressing? You heard about IP addresses? Yeah. You heard about MAC addresses yesterday? Yeah. So at TCP, if you remember, I don't know if I said or not, we are going to have port addresses. But in during the video part, I said you are going to have port addresses like 25, 80, 23, right? And your firewall is filtering based on this port addresses, right? So port addressing part transport layer does, like assign some address to a particular process, okay? Send messages, and again when you get back, depending on that particular port addresses, you are going to deliver to corresponding process. Okay. So port addressing part also transport layer takes. Connection control. So if you remember in OSI model, we had session layer, which was taking care of session establishment, session maintenance, and session termination. But in transport layer, I don't know. Sorry, in TCP/IP, I do not have session layer. So who will take that responsibility? Transport layer will be taking that responsibility. So it's something like whatever the presentation and session layer functionalities we have, those are divided among application layer and transport layer. Okay, we are eliminating those two layers and we are giving that responsibility to application and layer and transport layer and TCP/IP. So whatever the tasks we have there, like session establishment, maintenance and termination, we are calling here instead of session, connection establishment, connection maintenance and connection termination. Okay. So as I said, we are going to have connection establishment. Connection termination and connection maintenance. Okay, so basically it reads with IR, so it's pointing here and there. Okay, anyway, connection establishment, connection termination, and connection maintenance, these are the things. So when I say connection establishment, it is like before you can communicate with other destinations, uh, you will have to establish a connection. Okay, how you will establish? Any idea how you will be establishing a connection? In general, for example, if you consider a telecommunication network, how connection is established? You will first request, like you will dial, right? And a connection will be established, then you will be communicating and connection will be terminated when you keep the phone off. Right. Similarly, when we consider here also, there will be some sequence, like someone has to request the other person, like I want to communicate with you. Okay, once requested, a connection will be established. If the other person is available, then data transfer will keep on going. Then termination of that particular network has to go. Okay, so like that here also we will see in detail when we discuss about transport layer in later unit. Okay, but just now, here you remember, like someone has to request for the connection, it has to be accepted by the other, then only a connection will be established. Then you will be doing data transfer. Acknowledgements will be sent here and there, like I received the data, I have not received the data, like that. Then you will be terminating. Like both the entities has to close the connection. Okay, it's not like one entity will close and the other will keep on waiting for receiving the data. Okay, both should agree on closing the connection and they will be closing the connection. So all those tasks TCP has to do. Then error-free delivery. Why we are considering error-free delivery? What is the requirement? What is the requirement of error-free delivery? If you remember, this error-free, flow control, these two things we had in data link layer also, right? Again, why are we considering here? Any idea? So when I consider data link layer, we are considering error with respect to the bits or the frames which we are receiving. Okay, and when I consider flow control, we are trying to consider flow with respect to the bits or with respect to the frames which are being sent. Or you can also say data link layer is taking care of link to link error control, link to link flow control. Okay, so data link layer, it's like I have a node here, another node here, another node here. Okay, so between these two things, like that, your data link layer is taking error control and flow control. But when I consider transport layer, from here to here, it has to handle. Okay, from source to destination side, we are handling error control and flow control. But this is doing at the level of segments and packets, not at the level of bits and frames. Okay, that is the variation we have. So error free, I need to make sure like all packets are received without any error. There we were talking, I received all frames without any error. Okay, that is because of channel noise, disturbance, whatever we had. But this is like with respect to channel noise also you are going to have error here. But another thing is the condition in the network may lead to dropping of some of the packets. So I need to look into that particular thing. Okay. So flow control again, same thing. How many packets they are generating, how fast we are getting, whether I have buffers. Like basically TCP, it will have a buffer in which it will be storing data. If I have 1000 bytes of memory to store, okay, I cannot send 2000 or 3000 bytes at a time. Okay, I don't have memory to handle that, right? So whatever the size of the memory I have, accordingly the other person has to send the data. Okay, so that is comes as part of flow control. Ordering of packets in proper sequence. You're going to give some kind of sequencing. Okay, like as we said, segmentation and reassembling. Reassembling will be done as per the order. Okay, that is another requirement. Point to point service, like from one point to another point, or I can also twist and say like process to process service. Okay, from Facebook process to Facebook, Gmail process to Gmail. It won't happen like I am sending from Gmail, but my message will be delivered in Facebook. It won't happen, right? If you send from Facebook to Facebook, it will go to that only. It won't go to WhatsApp, Gmail, or any other thing. Okay. So process to process delivery has to take place. How it does process to process? Depending on this port address. So you are going to have port address for each and every process. Accordingly, that will be delivered there. Okay. So this is all about transport layer. You can just quickly note down some of the points. That light is sufficient or you need this? You need or no? Done? So basically we talked about process to process delivery and providing reliable service. That's how we are saying reliable process to process delivery of message. Okay, I have one process here sitting on this system and I have another process over there, and your transport layer is delivering from this process to this process. Okay, similarly your network layer, it is taking care of delivering from this particular computer to the computer over here. Okay, so that is a variation you should remember. Like each and every layer, physical layer from one hop to another hop, transmission of bits, data link layer, one node to another node or one hop to another hop, frame delivery, network layer, source to destination packet delivery, and the transport layer, process to process delivery of messages or TCP segments. Anything, it's fine. Okay. Then when I come to application layer, you are going to have several applications here, like as described here, FTAM X.50, 0, X.400, and they will be communicating with others. Okay. And it has protocols like HTTP, FTP, email, SNMP. These things we have seen in OSI model, right? Okay. Next I have encapsulation, decapsulation. Okay. So we are trying to communicate from this source. This source and this destination. So we are trying to see how it happens. Like encapsulation means one message when it comes from above layer to below layer, how it encapsulates. Okay, that process we will see here. So I have a message from application layer. It is giving to transport layer, and transport layer is attaching its header. It's something like message is taken from application layer and transport layer is encapsulating them. Okay, encapsulating means it is keeping inside an envelope and sending to below layer. Okay, so I can say segment encapsulates message. Segment encapsulates message. Transport layer encapsulates message from application layer. Okay, segment is encapsulated by packet, or packet encapsulates segment. Network layer encapsulates the message coming from transport layer. What is the message? It has header of transport layer and message coming from application layer. But network layer doesn't know what it is. It just looks at this information and says like, this complete thing is message to me. Okay. So this part. Okay. So this message plus this 4, the complete thing is considered to be data for network layer. And similarly 3, 4 message, the complete thing is considered to be message for the next layer. Like that they will be encapsulating. And see here at the intermediate product till network layer you are going to decapsulate. Okay, removing headers means decapsulating. Again attaching headers, encapsulating. Again decapsulating. This is how encapsulation and decapsulation works. Okay. So if you are attending any interview questions related to networks, they will concentrate on these things. Like packet encapsulates frame or frame encapsulates packet. Which is correct? Packet encapsulates frame, frame encapsulates packet. Frame encapsulates packet. Okay. So this is how the transmission happens. And if you are going down, encapsulation, going up, decapsulation. Okay. You can just note down that information. Packet encapsulates frame. Okay. Next, addresses. So at physical layer, we are going to term them as bits. We do not have any addressing there. Okay. Then data link layer, we are going to have frames, and you are going to have link layer address, or we can also call, in general, most of the cases we are calling it as MAC address, medium access control address. Then at network layer, we are going to have datagram, and correspondingly you are going to have logical address. Or at the data link layer, you can also say this one as what address we can say? Any other address? Physical address. Okay. Network layer, logical address, data link layer, physical address. Transport layer, you will be sending either segment or user datagram, and you are going to have port address. Application layer, you are going to have message, corresponding names you are going to have. Okay. So it's something like google.com. It's a name. And for that google.com, you are going to have a port address, you are going to have some IP address. Done. Next, multiplexing and demultiplexing. So, I may have several applications which are running. Okay, all those applications are multiplexed to utilize either TCP or UDP. Okay, I may have several applications, FTP, HTTP, like that. Any application may be there, but at the transport layer, they have only two options: either go with TCP or UDP. Okay, all these things, if I consider they are going with TCP, I might be using TCP or UDP, but they have to go with IP. Okay, so like that, when I consider multiplexing is happening at source side and demultiplexing is happening at the other side. Like this IP, it may be carrying the information of TCP or UDP. So demultiplex, again TCP, it may be carrying the information of FTP or HTTP, or again UDP, it may be sending the information of DNS or SNMP. So at source side, we are going to have multiplexing the information. At the destination side, we are having demultiplexing of information. Okay. Okay. You can note down quickly. Okay. Completed. So we have some internetworking terms here. Okay. So before going to internetworking terms, we will see video. to see how OSI model works.
The digital revolution has changed the way we work and communicate almost beyond recognition. Yet the smart, interconnected world we live in is still neither as smart nor as connected as we would like it to be. Until in the mid-1980s, the ISO, or International Standard Organization, developed a networking model to provide standards that will become the basis for network designs. This is the OSI model. 7 layers build up the Open Systems Interconnection, or OSI model. Let's take the flow of data and represent it with a train system. Sending a file or clicking a link in your computer ignites a flow of information. The first layer to receive the command is the application layer. The application layer serves as the window for the users and application processes to access the network services. This layer contains a variety of commonly needed functions, like resource sharing and device redirection. Data are packed and ready to take on a long journey. After the data is read, the next layer, or the presentation layer, formats the data to be presented to the application layer. It can be viewed as the translator for the network. This layer may translate data from a format used by the application layer into a common format at the sending station. It then translates the common format to our format known to the application layer at the receiving station. The presentation layer also encrypts control information into the data, in this case, the train, to be read by the next layers.
So they say here like your application layer may have represented in some manner, but that may not be understandable by the receiving application layer. So it's trying to do some kind of transformation so that the receiver's application layer will understand your data. It may have some control information also. It's trying to modify that into data. Okay, that's what the presentation layer is doing.
This layer allows session establishment, maintenance, and termination, which allow two application processes on different machines to establish, use, and terminate a connection, called a session. This session support, which performs the functions that allow these processes to communicate over the network.
Remember we said like port addresses will be there at transport layer, and you are going to have firewall which filters based on the port addresses. Okay, if a particular port address message is not allowed to go outside the network, then this transport layer is discarding those packets.
Packet filtering routers and firewalls sometimes take place in this layer. The lower the firewall in the layer is, the more secure the network. The data link layer. The packets are turned into frames for the specific networks. The data link layer provides error-free transfer of data frames from one node to another over the physical layer, allowing layers above it to assume virtually error-free transmissions over the link. A switch in networking takes place in this layer, where packets are read of its control information and then encoded with the media access control or MAC address. The MAC address contains 12 hexadecimal digits and prevents collision in the same media. Finally, the physical layer transforms the frames into bits, and then sent over the network via physical hardware or media, in this case, the Ethernet. Data are logically arranged and encoded before they get sent to a physical media to another computer, and is then received by another computer's physical layer. Some data or information in the upper layers are destined to be sent through the Internet, a vast interconnection of information and data. Either way, the data sent will then be received by the 7 layers of another computer, from the physical layer, which encodes the bits, back to the data link layer, where the bits become frames and is transferred error-free, to the network layer, where frames turn back into packets and then sent to the upper layers, into the transport layer, where validation and firewalls take place, sent up to the session layer, where connections called sessions are maintained or terminated, back to the presentation layer, where the data are turned back into a format that can be read by the presentation layer, and finally, sent and presented to the user via the application layer, where you will be provided with your request or command. So every time you click on a link on the internet or send a file from one computer to another, remember the journey the data have taken to make sure that everything is connected through a common network standard. The enormous complications the data must take just to serve you well, from the physical connections at the lowest layer up to the layer that has the user's applications, all wrapped up in a network model called the OSI model.
So as shown in the video, like each and every layer take care of their functionalities and provide services to the above layer. Okay. So this video is just animation, how it flows. Like in general, we won't have these stains and all kind of things, but flow is like that. Okay. Each and every layer, what are the responsibilities they are handling. Okay. Thing we have is some internet working terms we have here, like it's just some expansions of these things. What MIME, MIME stands for BGP, routing protocol, application FTP. Okay, so these things again in next classes we will be dealing with. Okay, this is just to introduce you, like you are going to have sometimes like TCP, UDP, SNMP, Telnet, MIME. Okay, IP, ICMP, OSPF, like that. So when I consider internet working terms, we have many things, like the first one, communication network. What does it mean? Communication network means we are establishing a network to connect different devices so that we will be able to exchange some kind of information. Okay. So that I can consider like communication network. And internet, it is like collection of different smaller networks, maybe by utilizing some bridges or routers. For what purpose we are interconnecting them? To have some kind of communication. Okay, that we can consider as internet. Then intranet. Intranet means within an organization, like within a college, within a company, we are establishing a connection. Okay, the information within that organization may not be going to outside internet. It may be restricted to fall only inside that particular organization. Okay, in such case we can have an intranet which operates within the organization. Okay, so for exchanging of information within that particular network. Then end system, the device which is connecting to the network, like it can be a mobile phone, it can be a computer, laptop, or a server. Okay, which is connected to the internet, that is called as end system. And intermediate system, like to connect between two end systems or several end systems, what are the devices which are having, which are being presented in the medium, like switches, hubs, repeaters, all those kind of things. Okay. Then we have what are the intermediate systems we have? Repeaters first. Repeaters are like it's kind of just dummy devices, we can say, which like they won't act intelligent, like whether I have to forward the packet or not. It's just like an amplifier. Okay, take the information and try to amplify. For example, zeros and ones are there. So if I can recognize this as zero, what is the voltage level I have to keep for that one? That we will be regenerating. If that is one, and generate appropriate voltage. Okay, so like that, copy individual bits between cable segments from one segment to the other segment. Copy and pasting operation this repeater will be doing. Bridge, it is little intelligent compared to repeater. It stores and forwards a particular packet on a data link, and it tries to look into errors. Okay, if no errors are there, it will forward the packet. Okay. Then I have router. which takes the packet and selects the best path out of available paths and tries to forward your packet on that particular path. Okay. Then transport gateway, this acts at the transport layer. Okay, it takes care of the functionalities of transport layer. Similarly, we have application gateway, which takes the responsibility of internet working, whatever the application programs we have. Okay, basically we will be seeing all these three things. We won't in general look into transport gateway or application gateway. Okay, if you see hardware devices, you are going to have repeaters, bridges, routers, but we won't ever see something like transport gateway, application gateway, something like that. Okay, mostly they are part of your software itself. Okay. So that's the end of this thing. Okay, so we have done with introducing you to thing like TCP IP, what TCP IP protocol suite is there, OSI model what it is, what is internetworking, some of the terminology, these things we have seen. In the next class, we will look into the details of guided medium, where we talk about taking physical layer, how we are transmitting the bits. Okay, like we might be sending through a coaxial cable, we might be sending through a fiber optic cable or twisted pair. Okay, regarding those things we will see in next class.